Everyone, welcome again in Eng-Man YouTube channel. So in this video, we will continue our learning on CO2 sequestration modeling using CMG software. All right, and in previous video, we have completed the run, with GEM, where we include water vaporization into our model. So we have CO2 injection, and of course, we will have, of course, structural trapping. And on top of that, we also enable the hysteresis trapping. And then you can see here, solubility trapping, mineral trapping, and lastly, we incorporate the water vaporization. Why? Because we know that at high injection pressure of gas, water around the wellbore can vaporize from liquid into a gaseous phase. Once again, we inject CO2 into our aquifer, saline aquifer, and of course there is gas, right? Sorry, of course there is water, there is brine around our wellbore, and if we inject, you know, gas, CO2 gas at high injection pressure, let's say supercritical CO2 at high injection pressure, it can vaporize the brine, it can vaporize the liquid around the wellbore into a gaseous phase. That's why we call this water vaporization. All right. And if you have water vaporization, you will also have, salt precipitation around your wellbore. And if you have salt precipitation around your wellbore, you can have injectivity reduction. Okay, so we complete the run and now let's see the result. Here we have the SR3. As usual, let's put it on our results like that. Okay, almost there. All right, expand. Okay, so let's just go directly to IK2D view. Sorry, it should not be the Barton Bandis. Sorry, my bad, my mistake. Okay, so instead, I'm going to remove this. And let's add this one. All right, the structural trapping, hysteresis trapping, solubility trapping, mineral trapping, and water vaporization. IK2D view. All right, let's start with the basic thing. Maybe this one. Gas saturation below the critical gas saturation, hysteresis dynamic trap gas saturation, play. All right, as usual, we are already quite familiar with this. That's basic. Let's fast forward. Done. And we are also interested in water mass density. Okay, let's start. All right, we are already familiar with this. You can see this profile, right? Because water, as CO2 dissolve into the water, into the brine, then the brine saturated CO2 or the CO2 saturated brine, it will be heavier than the rest of the brine. So that's why we can see the accumulation at the bottom of the reservoir. All right, and then, of course, the main thing here in our video here is, of course, due to water vaporization, we will have gas mole fraction of CO2. First, we have water mole fraction of H2O, initially fully water, and then you inject gas, all right? So, of course, the water mole fraction will be changed. And to confirm, we will also have gas mole fraction of H2O. It means the H2O turns from liquid phase, brine, which is liquid phase, into gaseous phase. Okay, to confirm that, we need to open gas mole fraction of H2O. Maybe I can go to the left. All right. And then let's go to gas mole fraction of H2O. No, no fraction, all right, at the start. No gas fraction of H2O. All right. But if you inject, you can have and you will have gaseous mole fraction of H2O this much. That signifies the water vaporization around our wellbore. All right, so actually that's it. And now let's just check. Maybe, well, CO2 injector. I just want to see whether we have injectivity. We don't have such parameter. Actually, I think group no, special history, I don't think so. Yeah, maybe let's start with special history. We should have CO2 supercritical, CO2 trap, okay, CO2 dissolve, all right, and maybe CO2 aqueous ions there, and CO2 mineral. Okay, there you go. And maybe if you want to check block properties, maybe, where maybe, let's find this location 1120 to 120. Let's start with this 1120. That's the location of the grid block. X1, Y1, and Z20. So maybe block properties, 120. And what do you want to see? Let's see, gas mole fraction of H2O. Okay, so you can see here. It will be great if you can see directly the injectivity, but I don't think so. Let's plot first gas rate. Okay, maybe delete. It's very short-lived actually, because we only inject 1 year.